Hello and welcome. My name is Eitan Suez, Technical Marketing Manager at solo.io. In this video, I will demonstrate how ambient mesh deployments can be made easy with Gloo Mesh's Gloo Operator. We'll explain the Gloo Operator and demonstrate installing Istio in ambient mode using the Gloo Operator. So in Gloo Mesh, there are two principal options for installing Istio, Helm and Gloo Operator. And in a subsequent video, we'll go over more of the details of the merits of each approach. But in this one, we focus on the Gloo Operator as an alternative mechanism for installing Istio. The Gloo Operator follows a Kubernetes operator pattern, and it may be worthwhile to take just a second to refamiliarize ourselves with that particular pattern. Here's a blog entry that I think does a good job of illustrating the concept. Right, there's this two pieces or two actors in this scenario. One is the operator, the machinery itself, and the other one is a custom resource that's exposed to capture desired state that the operator consumes or watches in order to realize that state or reconcile that state in your Kubernetes cluster. And so we say that operators encapsulate system-specific operational knowledge, using custom resources to define and manage application lifecycle tasks. So in the context of the Gloo Operator in Istio, the operator represents, essentially encapsulates Istio-specific operational knowledge. The types of things that the human operator would have to know are essentially automated through that operator. So it represents a higher level abstraction for installing Istio, one where platform operators do not concern themselves with the details. So specifically how this works, the custom resource in question is called the Service Mesh Controller. Here you see an example of such a resource that defines our desired state, our desire to have Istio running in ambient mode, installed in the Istio system namespace with a particular version 126.2 in this particular case. And we can look at the documentation to see what other sort of fields can be set on that particular resource. Some are more specific to multi-cluster installations, but we can modify other things or specify, for example, the image repository from which we fetch images, or repository secrets, and there's more such fields. It's important to also mention that to satisfy the need for advanced configurations, there is a complementary resource, a config map named Gloo extensions config, which can be used to control certain low-level aspects of the installation as well. All right, so we can contrast this with Helm. If we for a second take a moment to sort of look at the outline of the procedure to install Istio, the way we typically do it with Helm involves multiple steps. We have to be familiar with a variety of details. The fact in this case that ambient mode depends on the Kubernetes Gateway API, so we have to install the CRDs. We have to then deploy the base Helm chart for Istio, which brings in Istio's CRDs, and then there's a Helm chart for Istio-D, one for the Istio CNI agent, and one for the zTunnel component, the layer 4 proxy. So all of that knowledge is sort of encapsulated in the Gloo Operator, and we don't have to concern ourselves with any of this when we use the Gloo Operator. And so let's go ahead and demonstrate the usage of the Gloo Operator and see exactly how it works in practice. Let me go ahead and switch over to a terminal, and I believe I have a cluster running in GKE. Yeah. And we're going to use that cluster to install the Gloo Operator and then to deploy Istio in ambient mode. And to help me with that, I've got a little cheat sheet here with a variety of commands that will apply one after the other to explain more or less what we're doing. The first step is to install the Gloo Operator itself, and that's installed with Helm. Helm is, after all, the de facto standard. And so this command here will install the Gloo Operator in a namespace called Gloo Mesh. And once we have the operator running, we can perhaps visually inspect it. We can look at the pods in the Gloo Mesh namespace, and we see that the pod is not quite ready, and by now it probably will be in just a second. All right, so the Gloo operator has to be installed, and that's done with Helm, and that will come up in just a second. There we go. Once the Gloo operator is running, then we turn our attention to applying our service mesh controller resource. So let's look at that. Again, this is the same exact resource as we saw in the slides a moment ago, Istio version 126.2 in ambient mode. And so the idea is to apply this resource to our cluster. Now, the way that I'm going to sort of demonstrate this is we're going to try to watch the progression of the installation of Istio by opening another panel and running a kubectl command, which will look at the status section of the service mesh controller resource. Now, allow me to explain what that means. A resource whose status section is updated dynamically by the Gloo operator for us to be able to sort of inspect or monitor the progress of the installation. So when I run this command, I currently do not have such a resource even applied in my cluster, and so the command actually errors, but we're watching it every 2 seconds. And what I'm going to do on the other panel is simply apply this service mesh controller, and then we'll actually get visibility into that process by looking at the different status conditions that are exposed. So notice here, this is the initialization of Istio. The next step is the installation of CRDs, the installation of the control plane. And many of these statuses are currently false. And as time goes by, and the Gloo operator behind the scenes is reconciling our desired state to our actual state, Istio will be installed. And see if I can get a little more room on the screen here, so we could see that there's a phase called pending, and ready is true. That's interesting. And there we go. And phase is succeeded. So once phase turns to succeeded and all of these conditions are set to true, we pretty much have Istio installed. So if we look, for example, at the pods in the Istio system namespace, we see all of the components of Istio have been installed for us. We did not have to do any of that legwork ourselves, so to speak. The Gloo operator takes over that entire process. We can also type Istio version and see that Istio is installed in our cluster. We have the solo distribution of Istio 126.2 in ambient mode. All right, so that, yes, maybe one more thing we could mention here is the fact that it's through that service mesh controller resource that we can apply changes, right? So we can, for example, if we were to perform an upgrade on line 25, we could modify the version number, and the Gloo operator would then notice the discrepancy between desired state and an actual state, and then perform the upgrade for us. That's how that would work. Okay, and so here was an illustration of the utilization of the Gloo operator. I'm sure you understand the concept and the trade-offs, or the fact that we now encapsulate a lot of that operational knowledge in an operator. Thank you for your time, and we'll see you in a subsequent video.